Today I will show you how I can test my automation project effectively within the shortest possible time. For this purpose I will use the simulation framework Simit. Simit is a real-time simulation software with a user-friendly graphical user interface designed for virtual commissioning of automation projects. As a result, you achieve higher engineering quality and more planning security, whilst at the same time minimizing project costs and risks. For testing my automation software, I use a real hardware controller, a so-called hardware-in-the-loop solution. To connect to my real controller, I use an interface module, which enables coupling to the Profibus DP interface. Simit also provides additional coupling options, such as Profinet I/O, PLC SIM in order to be able to test without available hardware, as well as OPC and shared memory interfaces. I'll start by creating a new Profibus DP coupling. I will then import the system data blocks and the symbol table. All symbolic names and signals are now defined, which is sufficient for simulation at the signal level. But before that, I'll configure my interface module. The red bus fault LED is now switched off, meaning that my Profibus DP slave has been correctly recognized. I can now start the simulation and thus control and monitor individual values. In order to go on with an automatic test sequence, I now begin with the modeling of the device level. For this purpose, I use templates in order to generate simulation models automatically on the basis of tables. I'll show you how that works using the example of a drive unit. To start, I create a new diagram and select the drive component from the standard library onto my diagram per simple drag and drop. I now connect an input and an output to the component. And my simulation model is ready to use. I store this as a template so that I can reuse it repeatedly in other projects. I define my input and my output as variables. I can instantiate the template for future multiple use via the exported Excel table. Further on, I'll be using the standard templates contained in Simit. For multiple instantiation, I will use the import-export assistant tables provided by PCS7. I start the import by pressing the SMD button and selecting the table. All necessary equipment modules for my valve drive are now ready and could be simulated. I'll now do the same with my pumps. Select the template, confirm the SMD functionality, and import. All necessary equipment models are now ready and the simulation can begin at the device level. Both the process and the technological characteristics of the system or machine can be simulated in Simit, for example, in order to test sequential functions. You can model this either by using standard components, simply per drag and drop, or based on templates. In addition, users may define their own components. In this case, I will use templates that I've already created in an earlier project. First of all, I stop the simulation and then I select the template, the folder in which I want to store the template, and the table. As a next step, I select the next template. Done. Now it's time to test my automation functionality. I start the simulation, switch over to my tank model, and initiate the filling process. If I switch to the OS view, I can see that my filling level is rising. I then start the SFC. All valves are correctly controlled, and my reactor 1 is filled. The test is successful, proving that the automation program works properly. Since the simulation runs fully separated from the controller, I can take my automation project directly with me to the real plant. As a result, there's no risk of forgetting simulations in my controller. Virtual commissioning with Simit. Quick, flexible, and comfortable.